Hello to all of you. I'm Normand Mousseau. I'm professor of physics at Université de Montréal. I'm also scientific director of the Institut de l'Énergie Trottier at Polytechnique Montréal. Welcome for this presentation of the report number 1 of the 3rd edition of the Canadian Energy Outlook, an energy outlook that is also developed along with Paul E3 at HEC Montréal, with the modeling that will not be presenting today, but it will be coming in the next report by ESMIA consultant. Let me first present the Institut d'Énergie Trottier's mission. We have a mission in 3 parts. First, academic training. We are focusing on the energy transition, and we want to make sure to help the training of a generation of engineers, scientists, innovators who will understand these energy issues in their systemic way. We also support various research projects linked to this energy transition and to help us move forward. And we have also a large activity linked to the dissemination of knowledge on energy-related topics, and also of a discussion with governments and other stakeholders to see how we can move forward and reach our climate goals, especially in the energy sector. I should remind you that the Institut de l'Énergie Trottier is funded by a major donation from the Trottier Family Foundation. Our approach to working is through collaboration and to try to structure Canada's response to their goals, essentially. We've been part of the group who created the Canadian Climate Institute. We also have played a role in the creation of the Transition Accelerator and the Energy Modeling Hub. We are associated and we collaborate with the Canadian Center for Energy Information, Uranos, and a number of other partners, as well as the federal and provincial governments. Today, we are also publishing a number of work that is largely based on the work we do in the Energy Outlook. So we've published already 2 editions. We are at the 3rd. From this, we have built more analysis and better understanding of the issues, and that allows us to, for example, work on are we on the way or not to net zero at the Canadian level, at Quebec level. We've also looked at the electricity development at the Quebec and the Eastern Canada level with the strategic perspective study, where we look at the disconnect between the utilities investment plan, for example, and what will be needed to reach our climate goals. And the last of our major initiative was this Pathway Explorer, which is a collaboration with ESMIA, who has done all the modeling work for this initiative. And you can find on the Pathway Explorer, which is accessible, you can find it by Google search. We have tens of scenarios of decarbonization to 2050 with a number of very detailed graphs that you can generate and compare between the various scenarios and understand what the challenges are that we identify to 2050 net zero society. Today, we'll be focusing on the Canadian Energy Outlook. You will not have everything. Typically, we produce a full report. This year, because there's so much information, we decided to split our report, our outlook, in a number of reports. So the first one that you're listening today will be about the state of energy in Canada and state of GHG emissions. So we're looking at where are we today and how did we get here. In the next report, which we'll be presenting in a few months, we'll be presenting modeling efforts that will project our energy system to 2050, 2060, and analyze what are the trends and possible path to net zero for Canada. And in the 3rd part, we will build on these modeling scenarios to develop a series of reports on strategic challenges or themes that will both use the modeling results, but also expand in specific analysis, additional modeling, and additional thinking about this. So this is a whole year that we'll be taking on to publish this third edition. But let's start with the first part, report 1. That will be presented by Simon Langlois-Bertrand, who is a senior researcher at the Institute and is also the main author of this report.
Thank you, Normand. Thank you all for being here. So I'll try to tackle a series of objectives here with this webinar. One is, of course, the basic one, presenting the broad strokes of the energy system and GHG sources, as the title suggests. But this is mostly for those of you who may want to learn a bit more about some of the angles of the system that they know less about. So there's obviously a much greater level of detail in the report itself. I'll try to be as exhaustive as possible to really show you what's discussed in there, so that you can always delve into sections of the report where you find the topics particularly interesting to delve into. And of course, we remain available later on to answer questions even after the end of this webinar. There's also large themes or broad themes that I want to discuss throughout this particular presentation, given the moment of this publication. So one of those is, of course, the recent trends, but also another is whether or not we can now measure with a bit more precision and detail the effects of the onset of the pandemic in 2020, at least, and perhaps some of the lasting or absence thereof impacts. Also, whether or not we can see certain structural changes taking place in emissions and energy use because of policies put in place because of the pandemic and so on. A last objective is also to set the table, as Normand alluded to, for the second report and the analysis of net zero trajectories. So we're going to talk about this much more in the last one, but I'll try to keep this in mind as I go along here, presenting where we are right now as a starting point for perspectives about the future. So let me start with the system as a whole. So some of you may have seen this kind of chart before, so I won't go into the detail here, but I'm putting it for to give you a sense of, when people say, oh, Canada's an important energy producer, what this means actually, and really put in perspective some of the sizes of the energy flows across the country. So on this chart, you have whatever goes into the system on the left, so production and imports, and where it's directed towards on the right, so consumption at some point or another, but consumption in the sectors versus elsewhere in the world versus energy that ends up being lost, right? So I show this as a starting point for the discussion here, just to show, when we say this thing about the importance of energy production, what you can notice, even without looking at the fine characters on the chart, you can notice right away that the big lines are the gray line and the yellow line that you see on the left, really showing you the extent of, or the size of the production of oil and natural gas compared to everything else in the system. And a second point to make about this is that if you look, more to the right of the chart, you can see that most of these two very large lines actually do not end up in the Canadian sectors. They end up being exported, right? So also something to keep in mind along the way. The last point I wanted to show here is the magnitude of losses in the system itself. So that excludes the much more important losses of energy at the consumption point. When you put gasoline in a car to move around, for instance, you lose close to 80% of the energy content. But even in the system itself, you get quite a few losses. And if you look into some of the detail of this chart eventually in the publication, you'll see that all of this, or virtually all of this, comes from the transformation of fossil fuels in one way or another. Even the bar that you see at the bottom, which comes from electricity generation, actually refers to the relatively small share of, or nationwide at least, of electricity generation from thermal processes. So fossil fuels also here in this case, including uranium and nuclear. So let me talk about production a bit more. First, the fossil fuels. The table on the left shows you, a selection of data. We have a bit more in the report, but what I wanted to show here is enough for us to be able to look at the trend over the past 20 years and also a special focus around the years of the pandemic, right? So if we look at 20 years, you can see very clearly the spectacular increase in crude oil production, which has been more or less continuous over the entire period and still growing. So about 2.5-fold increase, 2.44-fold increase over time. You can also see that natural gas, that one is a bit more complicated. If you look at the entire period year by year, you will see more variation than is portrayed here. But nonetheless, we land at more or less the same levels as 20 years ago. But importantly, there are two very different reasons for these numbers. In the case of crude oil, you have the chart of exports on the right, where you can see very clearly that the increase in exports for crude oil basically explains most of the drive in the increase of production that you see in the table on the left. So in other words, we produce more oil because we export more, first and foremost, by far. Natural gas is completely different. So we produce about the same level of natural gas as 20 years ago, but we export much less today than 20 years ago. And that's because we use more, right? So to square that circle, of course, it goes to domestic consumption. So I'll get back to that one later. If we focus on the years of the pandemic, also very clear that extremely little impact of the pandemic on production. Small dip, non-negligible, certainly between 2019 and 2020 at the higher or the most important part of the shock. But this was from record levels in 2019. And when you get to 2021, in the case of crude oil, it surpassed those, set a new record, basically. Natural gas is a bit more stable and not a big dip for the year of the pandemic or the onset of the pandemic. Now, electricity production. So nationally, for a few years now, several years actually, production has remained more or less stable in terms of the total amount of electricity produced and in the Canadian or in the Canadian system, so the Canadian grids, plural. So around 60-30, 60-40 terawatt hours. Thinking about whether or not this is, this moves around quite a bit. So beyond intra-provincial transport, you get about a little less than 10% that gets traded and sent to the US. So relatively small part of the total. You also see that interprovincial trade, so whether or not electricity moves around across provincial borders, is extremely limited, so well under 10%, and that actually includes the link between Quebec and Labrador, which is at 32 terawatt hours out of 56. So it gives you a sense of how limited the exchanges between provinces or among provinces actually are. On the chart here, you see provincial grids, right, which is probably much more interesting and important to look at than nationally. The grids are overwhelmingly managed at the provincial level, and you can see that each province has a system that has very specific characteristics. And so you have provinces where hydro dominates, so that's the big dark blue lines. A little bit of wind power as well in some of these provinces. And then you get provinces where thermal is much more important, Alberta, Saskatchewan, Nova Scotia, New Brunswick. Note here that this is data for 2021 to have this full distinction. So it's a little bit misleading in the case of Alberta, at least, where you see a pretty big chunk of coal still. That's the red line. So that's more or less disappeared now, since the end of 2023, more or less, right? So most of it converted to natural gas, fired generation. But yeah, so small change, but still a lot of thermal production in that case. And then you see nuclear, perhaps. So just a reminder, it's exclusively used as a pretty big chunk of the Ontario system, with the exception of the one power plant in New Brunswick. If we look at consumption, so here on the chart, first you have the high level, total energy supply of the Canadian economy by source, right? And you can see basically two things here that jump out. One is that fossil fuels still represent about 82% of the total energy supply, and that's remained more or less stable over the past 20 years, right? So not a big change there at all. At a high level as well, you can notice that the most important change perhaps over that period is the increase, relative increase of natural gas, taking away shares from coal first and foremost because of the electricity sector So you had the coal or closures or conversions in Ontario, for instance, and in Alberta. But then that's the main change you see, right? The rest of it, things have been more or less stable for quite some time now. So we need to unpack a bit more where that goes, basically, right? So the supply goes to different places. So on this chart here, so this is 2021 breakdown of consumption. You have, I've identified on this particular bar the final energy part. So basically the part that goes to consumption in economic sectors, which is, I think, what we typically refer to in discussions when we talk about consumption, right? So in transport, in commercial residential buildings, in industry, agriculture. And then you have the other chunks at the bottom, which I want to point out are far from negligible, right? So the 9.9% is energy that goes to non-energy use, so transformed to become asphalt, for instance, or plastic and whatever else. And then energy that's consumed directly on the site of energy production in facilities that convert energies, for instance, so that it becomes a carrier that is usable across sectors or for specific uses. So in other words, the energy cost of having the structure of the energy system, the energy production system that we have, right? So I'm only pointing it here because this may be an under-discussed part of the discussion over or the debate over consumption and what to do about it. Usually we refer to mostly final energy consumption and then delve into sectors, but that's still 22% of the total, right? So that's a pretty big chunk of the supply as a whole. If we look at it from so this is the same bar 2021, but then we have the 20-year perspective. So we can see the changes mostly in the industry sector, right? Increase, pretty continuous increase over time. So that's the black bars that you see a third from the bottom. You can also see that for most of the period, transport kept pace in the increasing consumption with the industry sector. But of course, then you have the onset of the pandemic and a pretty important drop in energy use for transport. I'll get to that one in more detail in a few slides. You can also notice that for buildings, so commercial residential buildings at the top, things were a bit more stable over the entire period, which means that despite the fact that we have a lot of newer buildings, of course, that have been built over the past 20 years, energy efficiency in those buildings has become better enough so that it kept the increase more modest than the actual increase in the number of dwellings and so on. If we look at industry and its increase, which is sizable over that period, we should note that actually, if we look at subsectors, 41% of industry consumption in that chart actually goes to oil and gas production. So that means that, of course, it kind of matches the table I put at the beginning where you saw the increase in, the 2.4-fold increase in crude oil production. Right? So one of the most important sources of the change and the increase in overall consumption for the country. So unpacking the other sectors, I'll look at buildings separately as a standard here because, of course, the portrait is different. So if you look at residential building, so you have here consumption breakdown by driver, by source of by use. So the red bar is a pretty big chunk of the total for the entire period is space heating. Then you get the light green bar, which is water heating, and then the rest. You can see that, as we saw in the previous chart, more or less stable over the entire period. The main increase is in the darkish pink bars, which is appliances, which is a category that we have to understand includes, typical large appliances, as you can imagine, so refrigerators and so on, but also a lot of the electronic equipment that we saw increase in quantity substantially over the past 20 years. So individually, these devices don't consume that much energy, but overall, the change has been so considerable that you end up being able to notice the increase in the total consumption for the fleet of buildings. If we look a bit closer at space heating, since it is the biggest chunk, So we see that if we break it down by source, which is what you have for the 2020 bar, sorry, on the right there. So the breakdown by source shows you the extent of the importance, a relative importance of different sources, but also gives us a few bits of information so that we can understand variations across provinces. So you may be sitting in provinces watching this webinar in a province where most of the space heating you know about comes from electricity or comes from heating oil perhaps in a small region of the country, or from natural gas. And indeed, nationally, more than half of space heating, the main point of consumption in buildings, comes from natural gas. Electricity is a considerable second at 30%, but drastic differences across provinces. And I'll get back to the challenges that this create later on in the presentation. Just one word on water heating as well, the role of natural gas in buildings. So 70% of water heating nationally comes from natural gas, so a very large chunk of the total. Now, commercial buildings, I'll be a bit quicker about this one, but I just wanted to mention you can break it down the same way. And as you can imagine, space heating, given the Canadian climate, is also the main point of consumption, the main driver. The second here is auxiliary equipment, which is in many ways the kind of the equivalent of appliances for commercial operations. But importantly, you can see that this is where most of the increase over the past 20 years has occurred, and a continuous increase since 2020. So the red bar for 2020 is still much smaller than space heating, but this has grown very substantially, again, mostly because of the multiplication in the installation of all sorts of equipment, but mostly electronic equipment. Also space heating. Commercial buildings, we're at 82% that comes from natural gas nationally. So this is a bit more uniform, certainly compared to space heating systems in residential buildings. Transport now. So I wanted to talk about the pandemic effect in particular here. Of course, we've talked about this extensively over the past, almost 4 years now, I guess. So those of you who still doubt of the effect of the onset of the pandemic on transport, you can look at it. So this is maybe the largest difference that you can see using the indicator of energy consumption. So I've separated here on the left passenger transport, on the right freight transport, merchandise transport. And you can see that passenger transport is really where you see the biggest dip, actually going under levels from 20 years ago in 2020. So the rebound has been substantial in 2021, but still lower than the top we reached, or the peak we reached in 2019. So a few things to unpack here that gives us a few limits or a few caveats, certainly, to the statement that the transport sector or energy consumption for transport has been completely changed by the pandemic. One is that freight transport has not been affected that much, right? So compared to the drop in passenger transport, the drop in merchandise transport, while considerable in terms of energy use, is much smaller. And this is in the context of a substantial economic slowdown in 2020, right? So definitely not easily assigned to any kind of structural change, as perhaps can be discussed for passenger transport. The other thing, perhaps even more important, is that the drop in passenger transport energy use is largely attributable to the drop in demand for air transport. So this is the purple line that you see on the chart, and you can see the drastic reduction between 2019 and 2020 numbers. In fact, if we look at this with a different indicator, which is the actual demand for transport services, right, passenger kilometers demanded or consumed, I guess, by different people, 63%, close to 2/3 of the drop between 2019 and 2020 is due to simply the fact that many planes were kept on the ground and eventually restricted substantially, and eventually, of course, things going back to, we can't say 2021 definitely back to normal, but with partial numbers from 2022, 2023, we're pretty close, right? Definitely a substantial erasing of the drop that we saw, or that we witnessed here. All that being said, the change in passenger road transport is still substantial, just a smaller part of the total drop. And indeed, work at home and all sorts of measures have led people to drive less, or at least to consume less energy. To use that indicator first, I'll get back to that point in the discussion over GHG emissions later on. Now, just a few, before moving on to other topics as well, I wanted to show provincial variations. So one of the goals of this report and presentation. So of course, if you look at total consumption, intuitively, probably you say, well, if the province has a larger population, larger economy, probably consumes more energy. And indeed, so Ontario is the province with the largest overall production, which is probably what you expect. Then a second factor is probably, the structure of the industrial sector for a specific province. So Canadian provinces, most of them are relatively small economies. So the presence of a large sector may have a pretty large impact over all sorts of things, including energy consumption. And indeed, Alberta is second, despite a much smaller population in Quebec and even BC, because mostly of the presence of a large oil and gas sector, right? So that's one thing, certainly, like I said, probably more intuitive than anything else, but that we can confirm with this data. So this is for 2021. Sorry, I didn't put it in the title. But all that being said, I wanted to also show you, when you look at per capita consumption by province still, you can notice that these are not the only differences, the size of the population and the structure of the industrial sector. So here you can look at the fact that, yes, Alberta is first in per capita consumption, Saskatchewan is second. Part of that is the blue chunk at the bottom, so the size of the industrial sector, including oil and gas production in this case. But if you look a bit more closely, you'll notice other differences that are pretty important as well. So for example, if you look at agriculture in green for Saskatchewan, per capita, the size of energy consumption is much more substantial than the Canadian average or most provinces, even sparsely populated provinces. That's kind of the point here. If you look at, Manitoba, Newfoundland, and so on, something completely different in terms of the relative importance of consumption for agriculture. If you look also at transport needs, so freight transport is in orange, and then the brown-green bars are passenger transport, also much larger, for example, in Saskatchewan on a per capita basis, which tells us, that more questions need to be asked if you really want to wrap your head around the reasons for provincial variation on top of, presence or not of certain industries. Also something I'll get back to in a few minutes for GHG consumptions, where we even see other differences. A few words on Canada's very low energy productivity when we compare it to its peers around the world or other countries around the world. So on this chart, you have two measures, among others, and I'll discuss this a little bit here, but two measures of energy productivity. One is the consumption per capita, so that's the vertical axis, and one is the horizontal axis, which is energy intensity, so the amount of energy necessary to produce $1,000 of GDP. So if you look at the chart, the combination of the two puts Canada well outside of the pack. And it's worth noting that the pack here is not all countries. Of course, it's only high-income industrialized countries of the OECD. The exception not shown here is Iceland, which is much outside of all of this, but for very particular reasons. So removing it, Canada stands out on both indicators. And I want to point out that this is despite the fact that it's not like there hasn't been any improvements in energy intensity. For instance, over the past 20 years, Canada's improved reduced, I should say, its energy intensity by over 20%. So we need 20% less energy today to produce the same quantity of goods and services. And despite this, certainly the catching up has not occurred to other industrialized economies. So the interesting question, the important one, of course, is why, right? What explains this poor performance? And I want to put forward here and in more detail in the report again that there are several parts to this explanation. So one size fits all doesn't really help explain everything here, certainly. And so more interesting is to look at some of the parts of the puzzle that may be actionable, for instance, with different policy measures. So on the start of it, if we look at the industrial structure, sure, yeah, there's the impact of industries that are primary production industries where we produce basic products with little transformation, and these are energy intensive industries. So, steel production, for instance, or oil and gas production, and so on. That explains why, or helps explain at least part of why Alberta, Saskatchewan, for instance, if we put them on this chart, they would be well above on the vertical axis, well above the position that the average or the Canada as a whole is here, right? So that's definitely part of the discussion. However, we have to be careful not to limit ourselves to just that relatively simple statement. The overwhelming majority of subsectors in industry for the Canadian economy have an energy productivity that is much worse than almost all other members of the OECD. So we have a discussion of this in the report. With very few exceptions, Canada's either dead last or among the 3 worst performers for every subsector, almost every subsector, again, of the industrial sector, right? So does this mean that there's something more broad going on, or that, there's certainly not enough attention to this across the industrial sectors? Probably, right? So something to keep in mind as well. Now, if we look, is this because of the commercial sector? So commercial buildings and actors, are they more productive and get lost in the Canadian average? For the commercial sector, actually, if we look at one indicator, which is added value or value added, by energy consumption, it puts Canada at the very last place in the entire OECD. So similar to many sectors of the industry, definitely some room for improvement here. And now if you look at residences and households, here it's a little bit more complicated. So Canada's about middle of the road here in the OECD, a little bit worse than the middle of the road, despite taking into account, the harsher climate and so on. So even if we take this into account, Canada's around the middle, so seems to be at least a little bit better than the other sectors. But unpacking this, we know different things. One is that over the past 20 years, the energy efficiency of buildings has increased 24%. So that's good. However, at the same time, all building types, so single family dwellings, detached, attached homes, condos, apartments, and so on, they've all increased substantially the average floor space, which of course ends up canceling out the gain in efficiency. So that's why you have a more or less constant level of total energy consumption in buildings, in residential buildings over the past 20 years, despite a much larger fleet of buildings, but also not realizing, any kind of reduction. So in these times where we are considering the important lack in the number of dwellings available, and where we consider, to start building very quickly a substantial number of new houses and habitations, we have to certainly act on this very quickly to ensure that the impact on overall productivity or energy efficiency, if you will, is limited, or at least somewhat limited. Now, GHG sources and emissions. So the pandemic occurred or started basically in parallel with an acceleration of policies and regulations aiming to reduce more effectively and more substantially GHG emissions, mostly from the federal government, or substantially from the federal government, but some provinces as well. So one thing that's important looking at data and trying to unpack it in this type of analysis is to see, can the data tell us whether or not we can differentiate between possible impacts of the pandemic itself, so and distinguish also structural and lasting impacts versus temporary ones, and distinguish those impacts from other drivers of transformations, for instance, the price on carbon or different high-level policies at least. So when we look at the chart here, so you have up to 2021, and if you look at the difference, I'm going to talk mostly about the difference between 2019 and 2021 to try to understand. So there was a large drop in 2020 and then smaller rebound. So is that good news? Is that not? Can we understand this a bit better by looking at each of the point of emissions? So first, overwhelmingly, the reduction in emissions between these 2 years came from activities linked to energy. So that's about 53 megatons of CO2 equivalent. Almost all of the reduction came from there, with a very small additional 1 megaton reduction from industrial processes, mostly linked to, the economic context and no, particular transformations. Also, the emissions linked to the production of electricity and heat went down. That's a pretty big chunk of that 53 megatons. So it went down 9 megatons over these same 2 years. But as you can see, even on this high-level chart, so that's the light blue line at the bottom, you can see that this is one of the only sectors actually where there is no dip to speak of in 2020, right? So this is part of a longer-term trend, essentially as a result of the replacement or retrofit of coal-fired generation in Alberta, which is a very large chunk of the total here. So about 90%, close to 90% of the drop in emissions from electricity production. Now, oil and gas emissions. So basically, as you can expect, perhaps, given our discussion over the evolution of production levels earlier, the emissions came back to basically the same level in 2021 than they were at their peak in 2019. One change that is noticeable is a 20% increase in the emissions from refining in New Brunswick and Alberta overwhelmingly. So, is that an effect of the pandemic? It seems not. It seems to be simply related to the changing, conjecture with regard to economics and trade relationships on refined oil products in particular, and therefore not necessarily indicative of any kind of longer trend. Now, for buildings, so as I mentioned earlier, so energy consumption is relatively stable, but then there's some changes and certainly some transformation in parts of the building fleet. So if we look at emissions, we get a different portrait than what I said before. So one is an important part of this is that 5% of the emissions from the commercial buildings disappeared, or at least it went down 5% after 2019. And residential buildings went down 11%. So if you think about the onset of the pandemic, well, these two things are somewhat surprising. So first, 5% drop for a sector where a substantial number of office space were closed down or not used. Same thing for retail stores that ended up at the very least with shorter, opening hours and so on. So that's disappointing, or certainly much smaller drop perhaps than some had expected at the time. In residential buildings, well, if more people are working from home, it's maybe surprising that 11% of emissions went away. So it's not because all of a sudden we renovated 10% of the building fleet. It's because the winters of 2020 and 2021, which were much milder, right? A very large chunk of the explanation for these reductions is just a reduction of heating needs given the particular temperatures of those winters. So it explains over 80% of the change, which tells us also that for commercial buildings, it's even worse than perhaps would be expected. So the 5% drop, despite the closures and everything, was also despite a milder winter. So in other words, it would have gone down 5% regardless of the pandemic. So that is certainly something to keep in mind when thinking about energy management in commercial buildings and what kind of challenges there are there. Now for transport, just a word on emissions for transport. So emissions for transport between 2019 and 2021 went down 12%. But again, here, as I made the point earlier, the overwhelming share of not the share, sorry, but the subsector with the largest drop was air transport by far. So close to 2/3 of its emissions were wiped out between 2019 and 2020. So mostly following from the specific context and mostly rebounding or having rebounded since. Heavy transport for merchandise dropped to a much smaller degree, so about 7% at the peak reduction, and other sectors present different profiles as well. So basically confirming the distinctions and the portrait we gave earlier about energy consumption, but also showing that despite pretty substantial transformation or change in the use of energy for transport, the link with emissions is somewhat smaller. or the impact on emissions is somewhat smaller. And the last point I wanted to make before I reach the conclusion here is that we can also look at this from a provincial basis. And I'm going to show you even here per capita. And I wanted to illustrate that beyond, consumption of energy because of the presence of highly energy intensive industries, for example, oil and gas production, there are differences that are very important in the profiles of emissions of each province that come from other places in the economy of the respective provinces, right? So here you have per capita GHG emissions, but excluding oil and gas production, which of course tweak the total for oil producing provinces in particular. You can see that despite excluding the sector, you have Alberta, Saskatchewan, the main oil producers, still well above the pack here, well above the Canadian average. And you can see that the sources of emissions are varied, right? One of the explanations of this is the light blue bars, which is electricity production. So as I mentioned earlier, the bar for Alberta actually went down also a little bit after, again, this is 2021, because of the retrofitting mostly of coal-fired production. But you can also see one point I made earlier about the agriculture energy consumption in Saskatchewan. So this is reflected in emissions here as well, the green bar, which is much larger than any other province. And then also, transport. So that's the red line at the bottom. Here, I don't distinguish between freight and passenger, but Alberta, Saskatchewan, Newfoundland to a certain extent as well have much larger transport bars for emissions than other provinces, right? So unpacking really the challenges required, at least differentiating between these profiles. And, we need to be careful about the total versus, a measure that takes into account the weight or the size of the population of each, of course. So a few concluding points or observations, I guess, right? So this is the state of energy as of mostly 2021 data. I'll get to that one, but as of today, just understanding what lies ahead based on the information we have. One observation is that the dependence on the US market for the Canadian economy continues to grow with regard to energy production. So oil exports are now at above $200 billion per year. So that's about a third of the export of goods coming from Canada. And therefore, as a whole, Canada remains very dependent on its exports of oil and natural gas to a smaller extent to protect its trade balance, right? So one point to note here, certainly thinking about perspectives for net zero trajectory, is that this situation will not be simply compensated by any increase in the exchanges or exports of other sectors of energy production, right? So a few years ago, there was the discussion a little bit more than today about the potential to substantially increase electricity exports. But now we talk about it less because the spectacular growth in demand expected for the next few years, partly because of decarbonization efforts and partly because of changes in consumption and population growth, really puts into question the real potential of increasing electricity exports, right? So that is a really big challenge to try to understand or to try to imagine, what to do with regard to the economic impact of a much smaller share of these exports, for instance. Second point, the impact of the pandemic was, I'm going to use negligible. So the partial exception of transport, of course, I tried to discuss reasonably here, but certainly no impact on energy production. Relatively small impact on consumption, mostly temporary in any case. Same thing for GHG emissions. So maybe some opportunities missed there, but in any case, even with partial numbers for 2022 and 2023, we confirmed the rebound for almost all of these sectors and subsectors. And third point, we make this, we repeat this point every publication almost now, but the data lags make it extremely difficult to evaluate the impact of the policies put in place by especially the federal government since 2020. But I would say perhaps even more importantly for our own analysis, the results of the emission reduction plan launched published in early 2022. Even the price on carbon that's been in place for now close to 6 years at the federal level did not really was not really at a level perceptible or any close to substantial in 2020, a little bit more in 2021. So we'll have to wait to see if there's a more important impact for the levels of the price in the coming years. And with regard to the perspective, so again, like I said, setting the table for the second report. So one thing I would point out is that we have to be careful in not simplifying too much the variation and the challenges faced by different provinces. So they have different energy systems, they have different GHG emission sources. So of course they face different challenges. But I would point out that it's really important to keep in mind that it's not just the individual challenges, it's that there's a combination, a perfect storm, I would say, even for some provinces with regard to decarbonization efforts, right? So provinces which happen to have an oil and gas production industry are also provinces where most of the thermal fossil fuel fired electricity production has to be transformed, and they are also the provinces where the per capita needs for transport are larger, right? So the combination of challenges is really considerable. So we can't really limit ourselves to sectoral challenges or issues or technical issues. Second point, the transformations ongoing are certainly at an inadequate pace, for putting the country on a pathway to net zero. And what I will point out here, I'll get to the policies that are upcoming, of course, but one point I wanted to make here is that certainly the planning so far by the larger actors, not just governments, but utilities and distributors and so on, still remains lacking with regard to figuring out how to meet the needs of the transition in terms of workers, in terms of financing, infrastructure expansion, and so on and so on. And last point, of course, I have to draw a very important caveat to some of the stuff I said, given where the data stops. There are very important policies coming up or being implemented right now, and of course, they're not reflected in these data, right? So we can measure so far very few structural changes, but we have the clean electricity regulation upcoming, the cap on oil and gas production emissions, even a clean fuel standard being fully implemented. It is not reflected certainly in the data that we have so far. But I would conclude with this point, given the considerable number of these important measures that have been announced since the past 2-3 years, there really is an urgency to put in place a process that allows for the evaluation, a much more effective evaluation of these questions related to the implementation and the effectiveness of these policies to really keep track and be able to adjust as quickly as possible in the future. So I'll stop here, and I'm happy to answer any questions you have, of course, with Norma. So please put them in the Q&A section.
Yeah, thank you a lot, Simon. Sorry. Please, just while you're typing and preparing your question, let me remind you first that this was the first report, which is only about the state of energy and emissions in Canada. The next report will be about energy modeling. So in the next report that we'll be presenting in a few months, you'll see all these trajectories to 2050, 2060, and further analysis after that. You can also find the Energy Outlook will be available. The report will be available next week at the address which you can see on the screen, along with this video, along with the presentation, and along with all the data files for each of the figures that will be in the first part of the Outlook. So you can find all this information. So don't hesitate if you have questions. At the moment, it's fairly quiet on that side, so we don't want to keep you too long. But if you have questions, please do so now. Okay, can you foreshadow, please, some of the strategic challenges, subsequent reports, and collaboration potential?
Yeah, do you want to speak to that?
Yeah, I mean, one among there's a number of challenges that we already see, but some of them will be refined, of course, by our modeling. One of it is the growth in population. The population is growing much faster than what you look at the projection by Statistics Canada. We're going to much more something like between 65 and 75 million people by 2050. What are the challenges that come with this when we want to decarbonize and get to net zero? What are the possibilities that are being opened also by this growth in population? We also want to look probably at some economic sector, some cement or other very industrial sector, which can have which have its own specific challenges, and see how addressing these challenges can have impact also on the other aspect of the energy systems. And so those are two of the some of the one that we're looking at the moment. Question also, in one of your charts, you had J as the unit. I can understand megajoule, gigajoule, terajoule, but not petajoule. Can you explain, or is it a mistake?
Yeah, so no, petajoule is the next one after tera, I guess. So 10 to the power 15. Right?
So it may, if we wrote joule, it was for petajoule.
Yeah, probably.
How important is a carbon price to the transition? What should be done with the money brought in through such a pricing system?
Well, in the data presented here, definitely there's very little impact that is measurable, and surely that's expected given the the level of the price for those years. Now the question is, is it going to be effective now that it's getting to more substantial levels, so $80 per ton at some point, and therefore, well, 170, of course, down the road, but for now, this is where we are. So before we get data on this, it's very difficult to imagine how to evaluate whether or not there is an impact in the first place. We have to rely on modeling, and of course, this is much less efficient in terms of or effective in terms of evaluating the impact. But the money brought in, so far, the bigger it gets, the more the more tension it creates, I guess, politically, and therefore it's really difficult to foresee a situation where you get the rebate sent out by the federal government at the moment to compensate being eliminated, right? And you can talk to provinces that have gone through that particular stage, like BC a few years ago, for instance, trying to understand, draw some lessons, but nothing was done at the level where it's aiming for at the moment, right? So that's going to be a difficult situation for sure.
I might add that Quebec has avoided this by never returning the money, so it puts it in a green fund that it spends not very wisely, I would say, but it kind of keeps it. And somehow also by hiding the cost of carbon, it's not visible when you go to the pump, for example. It kind of it has avoided all this drama that we see in many other places across Canada, because I would say most citizens are not aware of the price on carbon. But whether you see the price on carbon or not, from the economic point of view, it's the cost of the good that you're buying that matters. And the money collected is going, in principle, to help reduce emissions. As I was saying, it hasn't been done efficiently at all in Quebec. Billions of dollars have not led to much reductions, but at least that's the aim of this program.
Yes, David Lazell has.
Yeah, that was the second part of David's comment. So if you spend it well instead of returning it, there's probably more impact on decarbonization, because you can help sectors where where it's hard to start moving, for example. Then you can accelerate the transition by reducing the cost of changing the technology instead of just returning the money to the citizens.
Yeah, I agree.
Any other questions? So I guess people are still digesting their lunch today. So if there's no other question, we'll stop here. So thank you, Simon, for your presentation. Thank you, all of you, for being here. We will, don't hesitate to write to us if questions come back to you in the future. Again, we'll send you an email next week when the report is online and all this information, and keep posted for what other activities we're doing at the Institut d'Énergie Trottier. Have a good afternoon. Have a good weekend.
Good afternoon.